beginning Unit 5, which is inequalities. And an inequality essentially is what it says it is, right? It means that something is not equal. So when we were working with equations, we were looking at two expressions that are set equal to each other. Now that we are working with inequalities, we are looking at two expressions that do not have the same value. One is either less than the other, one is greater than the other, or they could be less than or equal to. So we're looking at lots of different possibilities here. So real quick, we're just gonna go over what those symbols are for less than. So our less than kind of looks like an L, which is how I remember less than. Less than or equal to is the same symbol. We just draw that line underneath to represent that it can also be equal. Then we have greater than and greater than or equal to. So it says when graphing inequalities, the arrow should point towards the possible solutions. So when we graph our inequalities, we are graphing what are all of the possible solutions to the inequality. So for example, if we have x is greater than or equal to -2, it means that a number can be greater than -2, but it can be also equal to -2. So we use an open circle for less than or greater than symbols, and we use a closed circle for less than and equal to or greater than and equal to. And this is just to show that it can be that number. So you close the dot to represent that it can be that number. Like in the example above, it's a closed circle because it can be -2. And just to remind you guys when graphing, so at the top, I'm just gonna put a little number line. So remember that all numbers to the left of a number line are getting smaller, and all numbers to the right are getting larger. So if we have a number line, we'll have 0, 1, and 2, and -1 and -2. When we're going in this direction, it's getting smaller. And when we're going to the right, those numbers are getting larger. And this will help us when we're graphing. So for example, back to that x is greater than or equal to -2, we draw the arrow to the right because that is the direction of all of the numbers that are greater than -2. Okay, so I'm gonna do a few more examples for you. If I were to graph the inequality that b is greater than 3, well notice I don't have my numbers, so I need to first mark my number line. So I usually put the number that I'm working with in the middle, so I'm gonna put 3 here, and then we can just do 4, 5, 6, 2, 1, 0. You can go by ones, you can go by twos, you can go by threes. It really does not matter how you make your number line, you just have to be consistent with how you do it. So if you go by ones, it needs to stay by ones. You go by twos, it needs to stay by twos. So if b is greater than 3, I'm going to have an open circle because it does not include the number 3, and I'm going to draw my arrow to the right because those are all of the numbers that are greater than 3. If I'm looking at number 2, its n is less than or equal to -6. So I'm going to put -6 in the middle, and we'll just say this is -7, -8, -9. This is -5, -4, -3. Notice my smaller numbers are to the left and my bigger numbers are to the right. Well, it's less than or equal to. So that means that it can't equal 6. So we're going to close the circle, and all of the numbers that are less than -6 are to the left. So my arrow goes to the left. All right, let's take a look at number 5. It says 10 is greater than C. So we can rearrange this. If you like to have the variable on the left to make it a little bit easier, you can move it around. That just means that you have to switch the inequality. So if 10 is greater than C, then that means that C is less than 10. So I'm gonna put, so I have 10 in the middle, and then I have 9, 8, 7, 11, 12, 13. So it's an open circle because it does not include 10. And then all the numbers that are smaller than 10 are to the left. So less than is to the left. So you can keep it as 10 is greater than C. You just need to realize that when graphing, it's usually a little bit easier to read it with the variable on the left. So if C is less than 10, open circle on 10, and the arrow is to the left. You do not have to switch the inequality. It's up to you if you prefer to do that. All right, now we're gonna look at translating inequalities. So we have translated expressions, we have translated equations. You guys should be totally fine with this, right? We're very familiar with our key terms that represent addition, subtraction, multiplication, and division. So we are going to translate what the inequality is based on the word sentence, and then we're going to also graph it. All right, let's look at number 8. It says a number is at least 6. So if a number is at least 6, that means that it can be 6 or more than 6. So our inequality for this one is going to be x is greater than or equal to 6, because it can be 6, but it can be more than that. So I'm going to put 6 in the middle, and then we'll put 8 like that, 4. And this is going to be a closed circle, right? If it's greater than or equal to, that means it can be 6, and all the numbers that are greater than 6 are to the right. So our arrow goes to the right. I'll quickly do the rest for you. Number 9, it says a number is no more than -3. Well, if it's no more than -3, that means it can be -3, but it can't exceed that. So that means that this is going to be x is less than or equal to -3. So it can be -3 or anything less than that. We'll put -3, -5, -1. So closed circle, arrow to the left. And then number 10, a number is at most -1. So this is similar to that no more. So if it's at most -1, it can be -1, but it can't exceed that. So it's going to be x is less than or equal to -1. I'll have my -1. We'll make this -2, -3, 0, 1, so on. All right, so this is going to be a closed circle again, because it's less than or equal to. And these are all of the numbers that are smaller than -1. All right, moving on to solutions to inequalities. So just like a solution to an equation is the number that makes the equation true, it's the same thing with solutions to inequalities, right? So you just need to figure out, does that number make the inequality true or not? So all you have to do is plug in and check. So it says state whether the number is a solution to the given inequality. So number 11 says x is greater than -9. Well, let me plug in -16 for x. So -16 is greater than -9. Is this true? No. -16 is smaller than -9. So no, this is not a solution to the inequality. This does not make it true. Let's look at number 12. It says n is greater than or equal to 12. And we're plugging in 12 for n. Is 12 greater than or equal to 12? Yes, 12 is equal to 12. So yes, this is a solution to the inequality. Number 15, and we'll just skip 13 and 16, says b is less than or equal to 7/8 if b is 5/6. So we plug in 5/6 is less than or equal to 7/8. If you're not sure in your head comparing those two, if that's less than or not, then you need to make a common denominator to check. So our common denominator between 6 and 8 would be 24. So 6 times 4, so this is going to be 20 over 24. Is that less than or equal to 21 over 24? Because we have to multiply that as 7/8 by 3. Yes, that's true. It's less than or equal to. It's less than. So yes, this is a solution to the inequality. All right, so those are kind of the general topics with inequalities: graphing, translating, and solutions. Now we're going to look at actually solving inequalities. So it says to solve inequalities, you follow the same steps as solving equations. We are literally doing the same thing that we've been doing with all of our equations, except there is one little rule that you have to remember. And that rule says that if you multiply or divide by a negative number, you must flip the inequality symbol. So this is very important, okay? We cannot forget this rule. The reason why we have to flip the inequality symbol is because when you multiply or divide a number by a negative, you are essentially taking the opposite. You make that number become its opposite. Well, if you don't flip the inequality, it's going to end up being untrue. So if we are taking the opposite of both numbers on both sides of the inequality, we also have to take the opposite of the inequality that we're dealing with. So we end up having to flip it. So I'm going to show you an example of why we would have to flip it in the first place. So if I was looking at the inequality that 2 is less than 3, this is a true statement. 2 is smaller than 3. But let's multiply both sides by -1. So times -1 times -1. This becomes -2 is less than -3. Well, that is no longer a true inequality. -2 is not less than -3. -2 is greater than -3. So because we take the opposite, we actually have to switch that inequality. So if I multiply both sides by -1, then I should have -2, and I'm going to switch less than to greater than -3, and now this is true. Now this is a true inequality. So this is why we flip, right? Why we flip the inequality. So we're going to just look at some one-step inequalities to solve. So just like we did with one-step equations, it just means that there is one number or one constant that we're moving away from the variable. So if I'm looking at number 17, it's p minus 2 is less than or equal to -11. So I'm going to rewrite that as p plus -2 is less than or equal to -11. So I have to isolate my variable just like normal. So I'm going to add +2 to both sides. Add 2, that cancels out. Then we have p is less than or equal to -9. So this is my final inequality, and now I need to graph it. We always solve and graph. So I'm going to put -9, then -11, -7, and because it's less than or equal to, it's a closed circle, and I draw my arrow to the left because those are all of the numbers smaller than -9. All right, let's look at 18. I have k over 7 is less than 2. I'm just going to move this over here to have more room. So I need to multiply by 7 over 1. That cross cancels. Multiply by 7, and I get k is less than 14. So this is my final inequality. So we have 14 in the middle, that 12 and 16. It is an open circle because it does not include, it's not equal to 14. And to the left are all of the numbers that are less than 14. All right, let's look at number 21 as well. So we have 140 is less than -20 times j. So I need to get rid of that -20 by multiplying by 1 over -20. So that's going to cancel out and leave j by itself. Same thing over here, 1 over -20. Again, because I am multiplying by a negative on both sides, I must switch that inequality. So my less than is going to become greater than. And 140 times 1 over -20 is -7. So -7 is greater than j. You can leave it like that if you want, or if you want to write it with the variable first, just switch it again. So j is less than -7. So if -7 is greater than j, then j must be less than -7. Either one is fine. I do not care how you choose to graph it, or to write it. Just make sure that you graph it correctly. So I'm going to mark my number line. We have -7, -9, -5. It is an open circle, and those are all the numbers that are less than -7. All right, I want to take a look at number 23, just to address a question that I tend to get with our flipping the inequality. So if we're looking at number 23, we have 4/5 r is less than or equal to -8. So I'm going to just write this over here to give me more room to work with. All right, so to isolate the variable, I need to get r by itself. I'm multiplying by 5 over 4, so that all cross cancels to give us r by itself. And then whatever I multiply on one side, I multiply by the other. So I'm going to multiply by 5/4 on the right. Notice that yes, -8 is negative, but I'm not multiplying by a negative on both sides. Just because the number that's on one side is already negative does not mean we have to switch the inequality, because the number that I'm multiplying on both sides is positive. So we are going to leave this as less than or equal to. So I write less than or equal to -8 times 5 is -40, divided by 4 is -10. So r is less than or equal to -10. So we are not switching it because the 8 is negative. We would only switch it if the number we're multiplying on both sides is negative. And in this case, it's not. The number we're multiplying by on both sides is positive. So we're going to have -10, -8, -12. Less than or equal to means that it includes 10, and then we're going to draw our arrow to the left because those are all the numbers that are smaller than 10.